My name is Mackenzie Anderson. This is video project number 1. For question 1, it is to classify each of the following items. Sorry, my dog's moving around. The first one is chicken noodle soup. So that would be a heterogeneous mixture since it does not have a uniform composition throughout. It's made of a bunch of different items. B is oxygen. That is an element. It can't be broken down into substances that are simpler, even if it is through chemical reaction. That's as simple as that gets. Sugar, there it is. That is a compound since it's 2 or more elements combined chemically in definite proportions. Here's the 2 or more elements. And then air is a homogeneous mixture since it is the same composition throughout. Number 2 is to convert from grams to micrograms using dimensional analysis. So we are starting with the 0.065 grams. To figure out the micrograms, 1 gram equals 1 million micrograms. So those cancel out. So you take your 0.065 times it by that, and you get 65,000 micrograms. For 3A, there is 1 atomic number for H. That's because H's atomic number is 1. You get this, the proton is what tells you the atomic number. Oh, I wrote that. The protons correspond with the atomic number. For B, there are multiple possibilities for the mass number of H. The different possibilities are 1, 2, and 3. The subatomic particles corresponding to a mass number are its protons and neutrons. And then if there are 2 atoms of an element with different mass numbers, they are called isotopes. For C, it would have 1 atomic mass. There are not any multiple possibilities for that. The atomic mass of it is 1.00784 AMU. Here's the equation. I didn't write it very good though. So it's taking the average masses. So you take average mass 1 times the abundance, add it to the average mass 2 times the abundance, and then you divide all that by 100. For number 4, it's about copper sulfate. That is an ionic compound. Ionic compounds are usually composed of a non-metal anion and a metal cation. It exists in proportions that would give it electrical neutrality. So in the copper sulfate, the cation is copper, and the charge of it is 2+. The anion of it is the sulfate. The charge of that is 2-. So to name that, here is the name, copper 2 sulfate. So copper, Cu, is the first element of it. It has the 2+ charge. That is the Cu, the 2+. And then the sulfate anion is written after that. Sulfate. For the empirical formula, it is the simplest ratios of atoms in a compound. It is written with the smallest whole number subscripts. So C8H12O6, that's what I got for it. C4H603 or O3. And then to get the molar mass of it, so we want the molar mass of that. I wrote down each of the different elements of it. These are their molar masses. That's supposed to be 12.01. Then over here, so first is carbon, molar mass of 12.01. There's 8 of them, so it would be 8 times 12.01, 96.08 is what I got. Next one, hydrogen's molar mass is 1.01. There's 12 of it right there. I got 12.12. And then the molar mass of oxygen is 16. 6 of them right there. So you times those, and I got 96. Following that formula, add them all together, and that is the molar mass of the equation. And then to get the percentage composition, this is the equation you use. So we're looking for the carbon. So it's the mass of the element. Mass is 12.01. The mass of the sample, which was right there, 96.08. Divide those times 100%. I got 12.5. And then, sorry, my dog is moving again. The molecules in a 5-gram sample. 5 grams. Here's the total sample. Right there, that's how I got that. So I did 5 grams divided by that. That was the answer I got. Thank you.